Section 7.1, Adding and Subtracting Polynomials. We're going to start off with the definition of monomials. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. Remember that whole numbers are positive and there are no decimals or fractions involved. The degree of a monomial, that's an important vocabulary word, degree, of a monomial is the sum of the exponents of the variables in the monomial. And the exponents on numbers do not matter. It's only the exponents on the variables. The degree of a non-zero constant term, or just a number, is 0. And 0 as a constant does not have a degree. Here in this table we have a list of 4 different monomials: 10, 3x, 1/2 ab squared, negative 1.5 m to the 5th. Those are all monomials. They fit our description above. The first one is a constant non-zero number, so its degree is 0. The second one just has one variable, does not have an exponent shown, which means the invisible exponent is 1, and that's our degree. The third example here has 2 variables, a and b. Now the exponent on a is 1, the exponent on b is 2, therefore we add them together and we get the degree of the monomial to be 1 plus 2, which equals 3. In the final example, we only have one exponent on a variable, and that's the degree of the term, 5. In the next table we have 4 counterexamples, 4 things that are not monomials. 5 plus x is not a monomial because there are 2 things. Monomial means one term in the polynomial. A sum or a difference would not be a monomial. We can't have a variable in our denominator in the second one. We can't have a variable in our exponent in the third one. And with the fourth, x to the negative first doesn't have a whole number exponent. Now, if you were to rewrite that as 1 over x to the first, or just 1 over x, then we would violate the rule that we did with the second problem, where we can't have a variable in our denominator. So anytime we have a negative exponent in a numerator, we do not have a monomial. I want you to take this time now, find the degree of each of the following 4 monomials. You may pause the video, complete your work, and then check as you continue the video. Pause it at any time. Alright, and here you can see the 4 solutions to each of those questions about the degree of the monomial. If you want time to read through the explanation, pause the video now. Let's talk about polynomials. Poly meaning many. Basically, monomials are pretty boring. There's just a whole bunch of numbers and variables being multiplied together, and there's not too much we can do with them. But when we start to develop polynomials, which is a monomial or a sum of monomials, we can get more interesting problems. Each monomial is called a term of the polynomial, and a polynomial with 2 terms is a special case called a binomial. Bi meaning 2, like bicycle. A polynomial with 3 terms is called a trinomial. Tri, once again, meaning 3. Here is an example of a binomial, 5x plus 2. It has 2 monomials, 5x and 2. And a trinomial, x squared plus 5x plus 2. X squared, 5x, and 2 are each monomials. So their sum makes a polynomial, specifically a trinomial. Now the degree of a polynomial is based on the degree of each of its terms, and we want to find the greatest degree of its terms. If we're going to write a polynomial in standard form, then we have the exponents of the terms decrease from left to right. This is easiest to do if the polynomial is just in one variable. So if we just have x's or n's or y's, when we start to have x and y in the same polynomial, it can get a little more complicated. But the exponents decrease from left to right would put it in standard form. That's actually how each of my 2 previous examples are written. Exponent here is 1. There's no exponent here. They decrease from left to right. Exponent here is 2, then 1, then nothing, or 0. They decrease from left to right. In this case, we have a coefficient of the first term, which is called the leading coefficient. In this binomial, it's 5. In the trinomial, it's the invisible 1. That's the leading coefficient. Here's just another example of a general polynomial, no special name because it has 4 terms. 2x cubed plus x squared minus 5x plus 12. You can see that the exponents decrease from left to right, so it is in standard form. The degree of each term is 3, 2, 1, and 0 as you go from left to right, the largest of which is 3. Therefore, that's the degree of the polynomial. And 2 is the leading coefficient. And we do call 12 the constant term because it has no x involved. All right, let's see if you can write something in standard form yourself. I want you to write 15x minus x cubed plus 3 in standard form. Then identify the degree and the leading coefficient of the polynomial. Pause the video now to give yourself the chance to complete this task. All right, now we're going to reveal the answer. Take a minute to read through this solution. You can see that the final answer is written down here, and that in standard form this would be negative x cubed plus 15x plus 3. All the information that you need is right there. If you need to read through this, take the time to pause the video now. Just a little bit more practice. Take each of these 3 polynomials and write them in standard form. Then identify the degree and classify each polynomial by its number of terms: monomial, binomial, trinomial, or if it doesn't apply, just a general polynomial. Pause the video so that you can complete this now. All right, so now we're going to reveal the answers. And there you see, written in standard form, each of our polynomials, with the degrees identified and the type of polynomial that they are. Take the time now to read through it and double check to see if you have any discrepancies. When it comes time to add polynomials, we just have to add the like terms. Like terms have the exact same variables with the same exponents. There are 2 different ways we could set this up. We'll show both ways, either a vertical setup or a horizontal format. Start with a vertical. Vertical one means up and down. This is just going to look a lot like the traditional addition that you're used to with numbers. Then I have 2x cubed minus 5x squared plus x. I'm going to put that up on top. Below that, I'm going to line up the like terms for my other polynomial. I have a 2x squared, and I have an x cubed, so I'm going to actually have to move that out in front and make sure that I show that my 2x squared is positive. Now, the minus 1 doesn't line up underneath the x, so I can put it to the left and use zeros as placeholders. I don't need to write in plus 0 and plus 0x, but it might help you. Now we're going to complete a process that's very similar to when we first did elimination for systems of equations. I'm going to add straight down. 2x cubed plus x cubed is 3x cubed. Negative 5x squared plus 2x squared is negative 3x squared. X plus 0x is just x. And 0 plus negative 1 is minus 1. And that's actually just going to be your answer. Nothing else is going to combine. There's nothing else further that we have to do with it. So that method employed a vertical format, which may help some people line up their like terms and combine easily. Other people may prefer a horizontal format. In order to do that, we'll just use the fact that addition is commutative and we can move things around. I'm going to move to the front of this all of my terms with the largest degree. That would be 3x squared plus x squared. After that, I will put the next largest degree. That's plus x and plus 4x. And finally, I'll put my constant terms. Minus 6 plus 10. This is called a horizontal format because it's just going straight across as opposed to the vertical format which goes up and down. Now that I have these set up like this, I'm going to do some grouping. I'm going to combine 3x squared plus x squared, and that's just 4x squared. I'm going to combine x and 4x, and that's going to give me 5x. And I'm going to combine negative 6 and 10, and that will give me negative 4. And that's going to be my final answer over here. Now, in some circumstances, we needed to use a 0 as a placeholder, or with the combination through addition, we may actually cancel out entirely one of our terms. We don't need to include placeholders in our final answer. We wouldn't want to include a 0x cubed over here or a 0x to the fourth over here. It's only to be used in our work, and that's how you add together polynomials. After proofreading or proof watching, I realized there was an error, so don't worry, it wasn't just you. This actually should be a plus 4. The negative 6 plus 10 should be a plus 4. None of the rest of the explanations are changed by that. I apologize for the error. Subtracting polynomials is very similar to addition, but there's a slight twist that we need to pay attention to. Because we're subtracting the entire polynomial, we need to make sure that we're distributing that subtraction to each term in the second polynomial. We can use either the vertical or the horizontal setup as we did before, but what will probably be easiest is to rewrite it as an addition problem after distributing our negative. For my first example, I will set it up in the vertical alignment, and you'll see what I mean by that. And I have 4n squared. Now I don't have an n term, so maybe I use the placeholder of 0n plus 5 minus. Now what I'm going to do is I'm going to subtract this entire thing here. So I'm going to subtract negative 2n squared plus 2n minus 4. But rather than stick with it this way, I'm going to take this negative and distribute it to each of my 3 terms, turning this into an addition problem. That's going to replace this bottom polynomial with a positive 2n squared, a negative 2n, and a positive 4. Now I can just use the addition that this has become and once again combine vertically. 4n squared plus 2n squared is 6n squared. 0n plus negative 2n is negative 2n. And 5 plus 4 is a positive 9. 6n squared minus 2n plus 9, and that's my answer. On the other side, I'll just use the horizontal setup, but once again, I will first take this negative and distribute it to each of those 3 terms, in effect, changing each of their signs. The 4x squared minus 3x plus 5 will remain the same, but the second polynomial will become a minus 3x squared plus x plus 8, because the negative changes each of those signs. Now, like I did with the addition problem, I'm just going to combine everything together that goes together. 4x squared and the minus 3x squared, negative 3x plus x, and 5 and 8. Grouping together here, 4x squared minus 3x squared is 1x squared, or just x squared. Negative 3x plus x is negative 2x, and plus 5 plus 8 becomes plus 13. And that's my final answer here. Each of my polynomials is in standard form, and each actually has the same degree, which is 2. Let's look at a real-world problem that we can solve using addition and subtraction of polynomials. Imagine a scenario where a penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is just dropped from a height of 100 feet. The polynomials in the diagram to the right represent the heights in feet of the objects after t seconds. This figure is not drawn to scale, but here's the penny being thrown down, and here's the paintbrush being dropped. We want to write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So this distance here, which will actually change over time. We're then going to interpret the coefficients of the polynomial from part A in order to solve our question for part B. To figure out the distance, we're looking at a difference in height. So I'm going to take the height of the penny, negative 16t squared minus 40t plus 200, and I'm going to subtract from that the height of the paintbrush, negative 16t squared plus 100. Now remember that when I'm doing a subtraction of polynomials, I want to distribute my negative and turn it into an addition problem. So this is going to become negative 16t squared minus 40t plus 200 plus 16t squared minus 100. Now what's going to happen is this negative 16t squared plus 16t squared are going to be combined because they're like terms. I have nothing to combine with the negative 40t, so I just include that by itself, and I'm going to put the constants next to each other. Now I can group these together and combine like terms. Negative 16t squared and plus 16t, oops, that should be a squared, will be 0t squared. But because the coefficient is 0, I don't need to write it, so I'm not going to. The negative 40t doesn't combine with anything, it just is negative 40t. And the plus 200 minus 100 combine to be plus 100. And this is the polynomial that will represent the distance between the penny and the paintbrush after t seconds. Now what does this answer mean in terms of the context of the problem? Well, if t was 0, then negative 40 times 0 would be 0 and it would disappear entirely. T equals 0 is the beginning of this situation, immediately when the penny is thrown and the paintbrush is dropped. At that point, they're 100 feet apart. After 1 second, this becomes negative 40, which combined with the 100 will bring it down to 60. That means after 1 second, the penny and the paintbrush will be only 60 feet apart. So the negative 40 is the change in the distance over time. Because it's negative, the distance is decreasing at a rate of 40 feet per second. Now we could use this information to figure out when the penny and the paintbrush will meet up. Will it be before they hit the ground, when they hit the ground, conceivably after they hit the ground, which would mean that in order to meet in the air, they'd have to be dropped from higher up. Lots of different options. But the idea is that that is a polynomial based on the difference of two other polynomials, and we can use it to solve a real-world problem.